Okay. I think I'm going to try to get started now. First thing, I guess the homework two was supposed to be submitted. Does everybody agree with that? Okay. I'd like to see if there's any discussion at all of anything that people want to say about the homework. Is there anything that they found interesting? Do they want to complain about it? This is free discussion time, and so you're morally allowed to complain now. But more than that, did anybody find anything? Are there any things that happened on the homework that people want to tell me about? Um, Anything that, yes.
That I would like to ask you, why did the test data have any values? It doesn't make sense, right?
Why did the test data have what?
Any values, none. They had null values. Any n.
Why did they have null values? Okay. Now I haven't looked at the data set quickly enough, but what fields had null values?
There were many fields actually, which I had used. Even they had around 23,000. So few of the columns had null values.
Okay, and what kind of columns had null values?
They were not, some were categorical, like 1 and 0 kind of, and few other were named numbers and all. So values which contain.
Okay, so why would this have had null values? In general, I'll speak in general, and then if anybody had any other experiences, I would say one source of null values is if it didn't make sense for them to have the data for that field, for that record. Okay, again, whether this happened on your data set is not something I'm worrying about, but you could imagine a world where, let's say there was, operating system and version, okay? And let's say that there was one particular operating system in the world that didn't have versions. Okay, if they didn't have version numbers, then that would be left possibly as a null. Okay, so one reason may be that the data just, isn't relevant. The question isn't relevant for that record. Okay, you could imagine having a world where, let's say, you were measuring properties of different animals. Okay, and there was something in there about height and weight and length of tail. Okay, when we got to the humans in there, none of us have tails, right? So that would be perfectly good to put null. And maybe in that case, it should have been a 0. The other questions are, maybe there are things that you can't measure, okay, that are out there, but that they couldn't measure. And this I speculated, like the disk size for server configurations where it's not a commercial solid product, all-in-one product that you're buying, because then this information may not have been available. And finally, there's also times when somebody just goofed, okay? And which one of these are true in the data set, I don't know. But this is part of, again, why you do these kind of experiments. You work, part of the experience I hope you get with the data sets is that, again, as computer scientists, we're used to everything being perfect, okay? And when you're dealing with data sets, that's not always perfect. Okay, anything else that people found interesting? Any questions? Any observations they had that they were proud of? Anything they were embarrassed by? Yes. Some comments on the thing. Okay, good. So what was the relationship between the number of AV products and malware detections? So that's okay. So you want to know what the question was. So I don't actually know. Does anybody tell me? You guys did the assignment. I didn't do the assignment. Was there a relationship between the amount of malware and the prevention products and how much the likelihood of them getting hit? What was the relationship? Someone who did it.
It was decreasing when the number of antivirus was more.
You're saying that when they add more antivirus products, then that would be, you're saying it was less likely that it was something hit by malware. Okay? And that's presumably what antivirus vendors would want to have happen. And that's hopefully what should happen in an ideal world. Actually, do we think we learned something? Do you think that we can now publish a paper on this observation? Okay? or how true do we think this really is? One thing, again, first of all, I think for the purpose of the assignment, this is great, okay? Now, one thing that I haven't talked much about that I hope I'll talk, although I don't really have slides yet, so whether I'll talk about it is unclear, are questions of whether your data set has bias in it. Now, what fraction of the machines were, with your data set, what fraction of the machines were, had, basically were attacked versus not attacked, roughly? 50-50, okay? Now, 50-50 is great if you're trying to build something to tell attack machines from non-attack machines. Do we believe that 50% of the machines in the world have been attacked? Do we think it's more or less? Okay, I don't have a real opinion on more or less, but I doubt it's 50%. What I'm guessing is that they sampled and gave you, okay, half records that were attacked and half records that were not attacked. Remember, this is Microsoft, I guess the data came from, right? They have data on zillions and zillions of machines, and they didn't give you data on zillions of machines. So one thing that's probably true is that there are some biases that what they give you was not really kind of a random sample of the world, okay? So do I believe that things with more antivirus products are safer? I'd like to think that's true. But recognize that if we were using a data set, there are potential limitations. If you want to extrapolate from it, it depends upon the process that was given, that generated the data set. And here they were trying to not teach you something about how antivirus works in the world, but they were trying to have you build a classifier. And that sort of governs what the data set did. Okay? Any other questions or comments or observations? Let's just see what, there was another one on here. But what other things did we see here? I heard the scores do not matter, but auto increases the better the cleaning you do. So are people saying that their models did better after they did some data cleaning? Is that what how many people found that?
Professor?
Yes.
So my model was like at 51%. I just ended up cleaning the whole evening, and the more I cleaned and the better pre-processing I did, it substantially increased after that.
Okay, so you're saying you're happy you cleaned up, okay, and did data cleaning, and that's good. Hopefully it will improve the model, okay? And what cleaning things did you do that caused the improvements?
So basically I converted the categorical using one-hot encoding. Some of the data I included the mode values for the categorical values. For RAM processor data, I added the mean. So it's a lot of pre-processing with filling elements.
Okay, so there's a couple of different things that you're doing. There's a mix of pre-processing the data, meaning it wasn't just I took this table and ran it through a classifier and called it a day. Okay, part of what the improvements come from are pre-processing things like when you say one-hot encoding or not. That's not about cleaning mistakes in the data, but that is about making it in a better, more usable for these kind of models. Okay. So I agree with you that pre-processing, other than just taking the dumb thing and immediately running it, that's going to probably be a win. Okay. Any questions? Okay. Okay. There's a question on here about AUC. And that's AUC it says area under curve. That doesn't really tell you anything. Area under the ROC curve doesn't yet tell you something. There are different evaluation metrics for how good a model is. And we will talk about evaluation in a lecture in a couple of weeks. Okay, so I'll give the details of that later. Okay, anybody else discover anything? Yes.
So I plotted a region identifier versus the number of malware detected. So I think it depends on.
You plotted, what was it?
Region identifier.
Region identifier as what?
Versus the malware graph. Like how many are detected.
Okay.
Yeah. So I think some of the areas have more on attack.
Okay, so what you're saying, he said you looked at what you call it,
Region identifier.
at
Region identifier.
region identifiers, and you said that certain regions of the world seem to have more, corruption, if you wish, than other parts of the world, and that's something that makes sense to me. Okay, whether it's true or not, obviously there's certain countries that are famous for having a lot of hackers in them, and certain countries have less. And some of the countries with a lot of hackers in them, I am told, have deals with the government that says it's okay for you to break into computers so long as it's somebody else's computers. So it could be that that the regions with the most hackers are the ones with the least break-ins. Okay, so there probably are phenomena like that. Okay, you can imagine that certain countries, I gather these days, have internets that are more or less accessible to outsiders. And so you would imagine it's harder to launch cross-bound border things and stuff like that. Okay, could there be reasons why data cleaning does not result in particularly amazing gains? And so I would agree pre-processing is going to make some kind of gains. In this case, it's possible that real, straight, honest cleaning didn't make too many improvements. And one reason could be that the data set was relatively clean. Remember, this was gathered by Microsoft for a contest to be, where they were looking to get, hotshot machine learning people on it. You can imagine that the guy at Microsoft who put this thing together, did some things to make, basically work reasonably hard to make a clean data set. So that's probably the reason why, in this case, the data set may not have, I'm not surprised if the data set wasn't, dirty in certain kinds of ways. Okay? It's also about computer logging rather than about handwritten records. Okay? It's a different thing if you had a data set that was, some pollster was standing with a clipboard writing down names of people and what they thought about things. I can believe that there were more errors, recording errors there than in this kind of data set. Okay? So we will see, again, different data sets will be clean or dirty. It's important to be aware of the potential issues. Anything else exciting? Yes?
So I had a doubt that whenever we have we have outliers in a data set and some numeric values.
Yeah.
So we can take a log to lessen the amount of the significance of.
Okay, so the question was about outliers in numeric values. You could take a log, and now the numbers get smaller.
Yeah, but sometimes the numeric values are negative or it's zero. So how to deal with that?
Okay, so what happens when you take data and you take a log of it? Some of the values are zero and some of them are negative. Is this a problem? It isn't a problem to me. Okay, I consider this to be a feature rather than a bug. Okay, a log of zero just meant that the value was 1, and a log of of a negative log meant that the value was between 0 and 1. Okay, and so again, when we talked about ratios, logs were great for just this reason. And I don't know what field you talked about taking a log from, but if it's a world where 1/10 is as meaningful as 10, then taking a log and having the negative logs are great. Okay? If it's not a world like that, okay, then then maybe the log isn't the right thing to do. Okay, the original question was about outliers. And yes, the outliers will shrink. Okay, I mean, extreme values will come closer. There is still a question of, were those extreme values there for a reason or not? Just taking the log will make the problem smaller, but it doesn't mean that you shouldn't have eliminated these guys in advance. Okay, that would be a different way to deal with it. What maybe not appropriate here, but just speaking in the world. Okay, any other discussion, or if not, I can tell you I'm looking forward to, yeah.
What would you like to that like there's null?
Okay, say this again.
There's null in data set coverage, that is a missing data.
So the question is, if you have a null, is it missing data or not?
Yeah.
And the answer is, it depends, okay? Like everything else. You know, certainly when you see the word null, that's suspicious that it was missing data. But let's take a look at something. If you have a pointer that is null in a linked list, thinking back to our computing world, is that garbage or is that not garbage? Not garbage. It's there for a reason. It's a signifier of something. And sometimes it's a signifier of, you know, of a class, okay? So sometimes it's, we didn't know this value and so we didn't record it. And sometimes it's a, you know, what you call it, a signifier of something meaningful. Let's say that in our animal database we were talking about, we had a column that was length of tail. And your cat measured in 2 inches. Okay, the dog, 6 inches. Human, what should be the length of the human's tail? One argument might be null is more meaningful than 0, because there is no human going to have a, you know, a tail. Okay. Now, for your model, that may be a world that, you know, you would want to convert that null to 0. That might be an appropriate thing to do. Or it might be a distinct, something that you would later break the world into 2 classes. If the important thing about animals was that some had tails and some did not have tails, breaking them on null versus a number might be an interesting thing. You know, there's other animals that do have tails. Like, again, I'm railing on about this. I haven't thought about animals with tails before. There are certain dogs that breeders, for some reason, historically cut the tail off. Okay? This is a bad thing. Whether it's a bad thing or not doesn't sound like a good thing to me. But you could imagine there's a difference between a human having no tail and a dog having no tail. And that would be marked by the distinction of something that was null versus 0. Okay? And so that, again, that's my general thinking there. Okay, anything else people really want to talk about? Okay, so I think that's good. I can tell you the TAs are excited about grading the papers, and we'll get back to you with that later on. Okay. Now that we finished homework 2, I want to tell you homework 3 I have just posted. And I just want to go through and quickly what homework 3 is. It's going to be a similar thing in that it is based on you know, a Kaggle challenge. Okay, it's a different challenge, and there's going to be different things I want you to do with it. This one is about modeling sales in stores. So there is data that they have about a chain of stores. Rossmann is apparently some kind of European, I think, chain of stores. And you want to figure out for every store in the chain, what's its daily sales going to be 6 weeks in advance, up to 6 weeks in advance. And so, so that's the data set we have. We have a data set about a lot of stores and what their sales are on a daily basis. So what do I want you to do with it? This is the same boilerplate as last time. Again, I want you guys to, you know, basically take the different data sets, you know, integrate the store data about stores and the data about sales into a data frame to analyze it. I'm going to want to know questions about how are sales affected by holidays? Okay. In principle, we think certain holidays are probably good for sales in a store. certain holidays may be bad for shopping. I don't know if that's true or not. Is there any holiday in the world that is bad for shopping? I would guess sales in a store on Christmas Day are generally very bad. Why is that? Because the store is closed. Okay, the only one, so in general that might be true. They're probably, but anyway. So I want to know something about how sales in stores are on holidays. I'd like to know something about stores that have big stores that sell a lot of things, and little stores that that don't sell very much. And I'm curious, is the day of week behavior of the two stores separately? When it's a good day for one store, is it a good day for the other store? A bad day for one, bad day for the other. And and so that's what I'm kind of interested here. For the next one, we're interested in the effects of competition. Okay? One thing that the record data has is it tells you where its closest competitive store is. Okay? Do stores that are far from competitors, do they have better sales than stores that are close to competitors? I don't know if people have if anyone wants to bet, okay, or has a preconception. Is a store better off for sales if it has nearby competitors or does not have nearby competitors? Who here says the sales will be higher with nearby competitors? I hear one says, who do you think they will be good if they don't have nearby competitors? Okay, by a 2-to-1 ratio, people believe it's better not to have competitors. Why might it be better to have competitors that are close? Well, one thing, it may mean that you're located in a city as opposed to, the wilderness. Okay, I can guarantee you that the Nome, Alaska store doesn't have a competitor nearby. Okay, but so that might be it. It also might be that they put in stores where there are a lot of sales. It could be that if you have a store and it's selling great, what's going to happen? A guy will put in another store next door and take some of your sales. Okay, so I don't know. So we want to see something about how far the competitor is and how long the competitor's been there. Do the stores that are older do better? If your competitor is old, do you do better or worse than, if you're a new store, do you do better or worse than the old competitor? Okay. The next one's going to be about correlations. I want you to do a study of find out what features are interesting, and ignore that. Find out what features are interesting, and basically compute a correlation matrix between all pairs of interesting variables. And, does this make sense? Which ones seem correlated? How does this change if we use Spearman correlation? Part 6 is going to be about statistical significance testing, which we're going to talk about possibly next week. I think it's next week. There's this issue of, we can take any one variable and build a one variable model to predict store sales. Okay? Let's say that variable was something that's likely to be important. Maybe distance from competitor. Okay? What is a variable about a store that would likely be unimportant? Maybe the street number of the store. Okay, does everybody agree the street number, if it's located at 5, whatever road it is, it probably doesn't matter much if it's at 5 or at 15. Okay, I want you to build a model on one variable and then use a test to tell me, is this model better than guessing? Okay, regression is going to do its best it can to fit the data. Okay, but is it really doing better than chance? And that is what we use a permutation test to tell. So I'm going to want you to implement a permutation test to come up with a a p-value on how sure are we that this is doing better than chance, that it's a significant result. And we'll talk about that. Number 7 is about visualization. I will in the next couple of weeks talk about visualization in more detail. I want you to produce some interesting plots that tell me a lot about the store data. Okay, and we'll learn what interesting means, but that's kind of about visualization. Then there is this idea of just like the older one, you want to build a model. In fact, I'm going to ask you to build 2 different predicting models for the data. Use whatever technology you feel is appropriate. But I'd like you to have a model A and a model B. Okay? And I want you to score and experiment with it and try to make the models, decent. Then, with 9, I'm going to want you to tell me, are your models, do they perform differently? You could imagine having one model, okay, that scores 96%, and another model that scores 95% on the test data. Does that mean that the 96% model is better than the 95%? Here you're saying no. And the answer is, it depends. If you ran 1 billion training examples, test examples, and one model came in at 95 and one model came in at 96, I suspect that the 96% model is better. If you run something smaller, the difference may be basically due to luck. I want you to use a t-test here to try to tell whether or not your model is really better. Okay? That's kind of the question there. And finally, I want you to submit something to Kaggle and get a score. Notice at the end, the score is not that important. Okay? I mean, I want you to try to do as well as you can, but I don't want you to obsess that I must get a high score on this. Okay? Any questions about it? Yes?
In point number 6, we're supposed to make a model which does better than the chance. How do we compare our model with the chance? Is there a mathematical way to?
Well, there's a thing that we call a permutation test that I will tell you about when we get to statistical significance, which should be, I think, is within the next week. Okay? Any questions? Any questions on TV land? Okay. Okay, good. Any other questions about either homework? Okay, good. Okay, let's go back to the score, our section on scoring. Okay, this may be a problem. Hold on. No, good. Okay, so last class we started talking about scoring, ranking, and scoring functions and ranking, and I kind of convinced you that using your basic common sense and doing linear combinations of things is often a good way to do things. But I'd like to talk about four more advanced or maybe technically more interesting ideas for how you would compute ranking functions to decide how good something is. Based on what data the presumption is that you're given. If you were given, whether you're, what is the data from which you want to build your rankings? Now, I guess with the methods we talked about, like when grading students, okay, usually when grading students, you have columns of data so that, you have different fields and different numerical values in each field, and you knew which one was better than the other, and that's why linear combinations of things can be good. But there's different kinds of data you can be given. And one thing that's often used when you're given data are binary comparisons. What is a binary comparison? Your data consists of pairs of your universe of objects that you want to rank. And you're told that according to this comparison, object A is better than object B. Okay? What kind of data that you get for trying to build rankings could come by binary comparisons? Often when you think about ranking, you think in terms of sports teams or competitions. And typically, binary comparisons are team A plays team B. And one team wins and one team loses. If team B beats team A, does that mean that team B is better than team A? Not necessarily. Team A could have been taking drugs the night before or something like that, and most of the time team B would win. But it's certainly a vote that team B is better than team A. Okay? So when you when you think about sports competitions, they by definition give you a binary comparison. Sometimes when you're in ranking data, you're given, they ask experts, do you think team A is better than team B? Okay? And this I know is used in ranking, universities and computer science departments. Occasionally I will be getting how do you get reputational data in? Someone, some authority will email me and say, okay, do you think that Stony Brook is better than Buffalo? The answer is yes. Okay. Do you think, but they probably wouldn't ask me about Stony Brook, but they might ask me, what do you think about Montana State's computer science department against the Delphi universities? And, part of, this is obviously useful data for building a ranking from, but you got to, it's not numerical data. It's a binary comparison, and that's a good way kind of data. Now, when you are ranking universities, there's other binary comparison data that you don't really know. You came to Stony Brook. Did you get into any other colleges?
Yeah.
What school give me another school you got into?
North Carolina State University.
NC State. Now, is Stony Brook better than NC State if you were trying to build a ranking? Well, he thought so. Okay. Now, does he know what he's talking about? Maybe, maybe not. But you could imagine if you wanted to come up with a ranking of departments, a perfectly good way to do this would be to take data about who did, you choose. Okay. Okay. Given a choice, you take pairs of schools. This person decided to go to this school. They were accepted and had the option of going to that school. By the student coming here, that's a vote that this school is better. Now, did you get rejected from any schools?
Yes.
What school did you get rejected by?
Austin, Texas.
Austin, Texas. Now, this guy got accepted by Stony Brook and got dumped by Austin, Texas. Is that a vote that, now if we think about it, is that a vote that Austin, Texas is a better school, okay, than Stony Brook? And that Austin, Texas could recognize his limitations, where Stony Brook didn't. Or actually, more precisely, it's clear that the applicant pool they had to choose from was such that we might be excited about you and they might not, right? So does everybody see how you can interpret a lot of things by binary comparison data? Okay? Any questions about that? Now, one way to interpret binary comparisons would just be to count how many times people, won the election, right? So Stony Brook, people who came to Stony Brook got rejected from a certain number of schools. People who rejected Stony Brook picked some other schools. One way to do it is just simply to kind of think of a one-loss type of percentage, right? Stony Brook, people accepted Stony Brook's offer 52% of the time. They rejected it 48% of the time. Therefore, Stony Brook's a little bit better, but not better than a place that got rejected 80% of the time, but less good than a place that got accepted 60% of the time. is just tabulating the number of votes, the meaningful, okay, or not. If you want to interpret these votes data, is just counting how many votes each team got, okay, how many wins each team got. Is that sufficient, or might there be more information in the votes than just the count? Okay, well, let's think in terms of sports teams, which I still think is a better notion here. Okay, is the number of wins that you have versus losses the only measure of how good the team is, or could you know something else as a result of those comparisons? What else would you know? Yeah? You're saying there's national and international level. Now, if we just count wins and losses, and they're not playing the same competition, this is a problem, right? Stony Brook could conceivably, in football, let's think about something meaningful. Stony Brook's football team could conceivably go nine wins and 2 losses some year, okay? Have a very good year. Texas Austin, which we had just talked about, could go 9-2. Okay, would that mean that the teams are the same? No, because there's a big difference. There's certain leagues in football where the real football teams are. And there's other ones where they just put uniforms on guys and send them out, right? So the competition makes a big difference, right? And just counting wins and losses wouldn't do it. Is there something else that just counting wins and losses might not be fair? A little more subtle thing, not just competition. But what if they didn't play the same number of games? Okay, you could imagine somebody's team started, or maybe one league started their season earlier, right? Let's say that Stony Brook had a rejection date, a time you have to accept our offer by that's later than some other schools. If we get back to the graduate thing, right? You could imagine there would be less people rejecting Stony Brook until later in the term. Okay? So how do you compare for things when you don't have equal counts? Okay? And so this notion of not equal counts and different number of games, okay, are what we need a smarter method to consider. Okay. There's a question here on the TV about the binary comparisons. Okay, good. Come on in. Okay, this is the midterm that we're giving today, correct?
Yeah.
Okay, good. Put it down.
So just be careful with the boxes.
Yeah, it got everything there, right?
Yeah. I got one more version one on the top.
But everything's in the box. Go get it there. Okay, put it all in. Yeah. Okay, great. Thank you. Okay. The answer is yes, that is the midterm that I'm giving today. It is for another class, however. Okay, so don't get too nervous with that. Okay, the question was, binary comparisons will generate partial order. How do we turn the partial order to a total order? That's another way, it's saying that there's another way to think of these binary comparisons as a network, and we'll talk about that later. Okay, I want to use a different method first before we think about things on rankings. Okay, Elo rankings are a famous way of coming up with kind of performance scores when you have a world of ranked comparisons. And the method works by the following, is kind of governed by the following kind of formula. Basically, we're going to start out all themes at the beginning. If we know nothing about them, we presume that all themes are equally ranked. Okay? If you know something about them, maybe you'll give higher scores to one team and lower scores to another team based on what you know. But regardless, there's an initial score. And in general, what do? We are going to, after every match, update the ranking of a team. So how should Team A's rank score change after a match? Well, it should be A's rank score after the match should be the score it had before the match, the rank before a match, plus any change of opinion as a result of the match itself. Okay? If it won, we would like to think our opinion goes up. If it lost, we would like to think its score went down. And so what is the change that we want to make to a team's ranking? I'm going to say it's going to be some constant K times the score of the match for A minus the expected outcome of Team A. Let's think what this should be. If we thought Team A was a horrible team, and they're playing a very, very good team, and they lose, do we change our team's opinion of Team A very much or not? They were a lousy team. We thought they would lose. They lost. Okay? Does this mean they're worse than we thought? Not really. Suppose it was a lousy team that won. Okay? Now we think that it should be, and it was playing a good team, and it won. Then we would really want to improve its score, right? And what if it was a lousy team playing another lousy team, and it won? Well, its score should be improved, but probably not by as much as when it beat the really good team, right? When it played another lousy team, one of them had to win, okay? So what is the idea here? S sub A is the outcome of the match for Team A. If it won, S of A is 1. If it was going to lose, if it lost the match, the outcome was -1, right? And I guess a tie would be a score of 0. That seems like a reasonable thing. Mu of A is what the expected outcome for Team A was. Team A was playing Team B. A had a ranking. B had a ranking. We can compute what the probability was that A should have beat, if our rankings were right, that A should have beat B, or A should have lost to B. And with that, we can get an expected value of the match before it was played. Then, the difference between the result and the expected result, we're then going to amplify by a constant K that's going to announce the maximum swing between the teams. Any questions about that?
Expected value will be from the distribution or from the ranking previous.
So the question is, for this to work, you need to know what is the expected value that A should have beaten B. What is the expected value of A that A should be beaten B? Well, I will say that the expected value it wins clearly is going to be this, but that's only going to pass the question that you have to the next slide. What is the expected value of A winning? Well, I claim it is 1 times 1 is what we get if A wins. So it's 1 times the probability that A beat B plus -1 times the probability that B beat A, or 1 minus A beat B, right? It should be clear that if we could figure out what the probability was that A should beat B, okay, this will give us what the expected value of the match is for A. Okay, does everybody agree with that? If we know what the probability is A should beat B, the expected value of the match is what? The sum, expected value of anything is the sum over all values all possible values of this random variable, which in this case is either win or loss, okay, -1 or 1, times the probability of that outcome, okay? And the real part of your question, though, is how do I compute what's the probability A should beat B? And it's clear that for this to work, it's got to be a function of the ranks of A and B. In particular, the difference in the ranks between A and B. Okay? What do we want the probability? What should be the probability that A beats B if their quality scores, their ranking is the same? What should be the probability that A beats B? A beats B should be 0? What? 0.5. It's like it's flipping a coin, right? If we have the same quality scores, it should be a 50%. The expected value of that match would be 0, right? Because I have a half chance of a -1 and a half chance of a 1. Okay? So what would be a good function to compare the two ranking functions, to compare the, to take the ranks of A and ranks of B and convert them to something between 0 and 1 that is a probability that A beats B. We need a function with the following properties. As we said, if the difference between the rankings of the teams are 0, the teams are the same, and we would expect that the probability should be a half. If the difference between the ranks of one team and another is huge, then what does that mean? If A has a much, much better ranking than B, what's the probability that A should beat B? Should start to approach 1. And if the difference is very highly negative infinity, Team B must be much, much better than Team A, and the probability of Team A winning should approach 0. What function will have that property? Okay? There's a function that we're going to use several times in this class called the logit function. The logit function is the logit of Z is 1 over 1 plus e to the minus z. Let's look at this function and what happens. If z is 0, what is e to the 0? E is everyone's favorite number, 2.718, ... Okay? What is e to the 0 going to be? 1. 1 over 1 plus 1 is indeed a half, right? What if e is going to be, if z is going to be infinity, very, very large, okay? E to the minus infinity is e to the 1 over infinity, 1 over e to the infinity. That's 1 over something very huge, that is 0. Does everybody see that this approaches 1 as z gets bigger? And likewise, if z is negative, e to the negative infinity is e to the infinity, okay? 1 over e to the infinity is going to go to 0, okay, as z gets, as z gets large, okay? So this function satisfies the 3 requirements that we have and has a nice shape to it, okay? It approaches asymptotes where we want. And this is the logit function. And this is how we're going to map the differences in scores. Okay? If this is clear, okay, then, okay, let me see what the questions on TV are. Okay? There's a lot of talk about ELO systems. Okay, so there's somebody, I don't know if you want to explain this someone wants to speak it out. There's something about using ELO rating system on online games, okay? The claim is that you're often under or overrated, okay? Okay. I am not sure I understand that question, but I'm going to want you to ask it in a minute, okay?
So-
Let me go finish.
Okay.
Ask it now if you want. What's the question?
So the thing is, how would you know that you're accurately rated? Because a lot of these times you don't actually know if you're overrated or underrated, and it takes a lot of games or a lot of matches for
Okay,
it to be
so
accurate.
the question of how do you know if you're accurately rated? Well, one way to, okay, so one what we agree is this is a procedure that, based on the outcome of matches, will give you a score. Now, how do you tell if it's doing a good job or a bad job? If it's doing a good job, I would like to think that usually the outcome is going to match the predicted outcome. If you want a statistic of, you could easily compute a statistic on what is the distribution of differences between the expected outcome of matches and the outcome of matches. And what I would like to think that that distribution should look like, hopefully it's centered around 0, meaning that it's, that the most likely score difference observed is 0, and hopefully it's relatively tight around 0. If it's tight around 0, that would mean that most of the time, this is the frequency, is the x-axis. The y-axis is this delta. Okay, the difference between the actual score and the expected score. If the scoring system is doing a good job, it should be usually making good predictions. If it was always making perfect predictions, you didn't have to do it. You had the original scores and it never changed. Okay? But the hope is that how good it is doing can be measured by what the errors are. Okay? And I guess your concern is you need to have a certain number of matches if you're starting from scratch, and there really is a big
Yes.
difference between people. Okay? Then then there is, there might be a lot of noise in that at the beginning. Or you could imagine a match where, a kind of sport where the comparisons aren't that good. So you're complaining about some kind of a video game. I don't know what video game you're complaining about. But I could imagine, what are the chances that a monkey would beat you at this video game? Okay? You could imagine that certain kinds of games have a large chance component to it. Okay? I don't know what, chess has a very small chance component to it, right? I could imagine that certain video games have a fairly large chance component to it. And if so, then you would not expect to get that much information about a player from this method. Suppose we were looking to see how good you were at coin flipping, right? Guessing whether the coin, you're going coin flipping against the other guy. If it's really 50% per match, sometimes someone's going to get lucky for a while. Their ELO score would go up. Sometimes they're going to get unlucky for a while. And but in that case, it's not really measuring big skill changes. So my instinct is that is the reason why, one reason why you may not be satisfied with the results of the ELO ratings for that game. Any questions? Okay. So, yes.
So I was just wondering whether these rankings are more on the current form of the teams rather than the overall performance. Like, let's say in this year, a particular team is better. So
Okay, so the question is, what happens when team skills change? And that certainly happens in many endeavors. Maybe the best player on your team breaks a leg, or they get new players, or something like that should change. It is clear that in this case, the change in ratings would mean something. And the more games you win more recently, that's going to cause your score to go up. If you're beating teams that were seemingly much better than you, then they're going to go up faster, right? And so one of the good things about this is that it is somewhat dynamic. How dynamic is it? It depends upon this constant K, which is going to measure how much of a swing do we allow on the basis of a single match. Okay? If K is large, the scores are going to jump all around. If K is small, they're going to need a lot of evidence till they're convinced you're really much better. Okay? Any questions about that? Okay, here is a example that I had where, again, ELO is famous because it's the ranking system that people use in chess. Okay, does anyone know what ELO stands for? Doesn't stand for anything. It's named after a guy, and his last name was ELO. That's ELO. Okay, but what is this example? Suppose Steven Skinner, who's a terrible chess player, ranking 1200, played Garry Kasparov, whose ranking was, he was the best in the world. I think he had the highest in the world, at least until very recently. Actually, yes, until Magnus Carlsen. Suppose I beat Garry Kasparov, okay? The difference in our rating is such that this would be a miracle. And if K, the maximum swing in chess, I think, is 40 points each way, which means a total of 80 points shifted. If we did this, my score went up 80 points, and Kasparov's went down 80 points. Notice that you're taking points from the opponent. That's the other thing that's interesting with this scoring system. If I gain points, because I did better than expected, the other guy did worse than expected, and they lost the same number of points. There's a conservation of the number of points in this system, is one of the cool things about it. So now I've got 80 more points than before. Suppose Judith Polgar, who I believe was the best woman chess player ever, played Magnus Carlsen, who's the highest scoring man ever. Suppose Judith beat Magnus. Okay, it would be an upset, but it wouldn't be an act of God. Me beating Kasparov would have been an act of God, right? And so far fewer points got transferred. Still a sizable number, but I think it was like 50 points got transferred or something like that. Now at the end, suppose I play Judith Polgar, and Judith Polgar wins. Well, no points pretty much get transferred. It would be a miracle for me to beat her. Okay, and so I mean, 0.00000001 points probably got transferred from me to her if we played. Any questions about that? Any questions about this ELO method for ranking things? Okay, it's a nice little system. You saw it if any of you remember seeing the movie The Social Network. There was a famous scene about with Mark Zuckerberg where he used this. Okay. Any questions or comments about ELO rankings? Okay, good. What other methods of building rankings are there? Well, sometimes you have multi-party votes, that it's not only a vote being a binary comparison, me against you, but often a vote is a ranking, an ordering of all the candidates. So actually in the United States, there's some places in the United States that are shifting from a world where when you go to, right now when I go to the ballot box, at least the last time I went to a ballot, out here when I vote, okay, I'm given a bunch of parties, and I pick the candidate that I want most. Another idea that is gaining traction is if you have a lot of parties in any election, no one of them may very well get the majority of the votes. Sometimes there's two very, very similar parties, and I don't really care too much, if it's from party A or party B, but damn it, I don't want party C at all. Okay? There's different schemes when you have a world when you've got more than two parties. What's the best way to get feedback from voters? Okay? A natural way is to actually have them rank all the candidates. So what is the best computer science department? You could have ask people pairs of departments, or you could say, here are all the departments, you rank them from best to worst. And if I filled out my ballot, Stony Brook's ahead of MIT, well, that's something, okay? Any questions? So if you get data now, where the data is a set of rankings of things, you need a method to take all the rankings and combine them. So what is this thing, this data here? This data is a world where we have 5 items and 4 voters. Each voter ranks all of the candidates, all of the candidates from best to worst, okay? How can we decide a winner of this how can we convert this to an ordering of the candidates from best to worst? Well, one way is to assign a point total to each position on the list, and then basically give everybody a score based on what for each position that they were in, how many points do they accumulate from that, and convert it to a direct point thing. So if we assume that the points to being first was 1, second was 2, 3, 4, 5, item A should accumulate a total of 1, 2, 3, 4, 5 points. Does everybody kind of get that? Item number D should accumulate 4 plus 4 plus 5 plus 3 points. 4 plus 4, 8 plus 5 is 13. 13 plus 3 is 16. D gets 16 points. Does everybody kind of get this scheme? This is a pretty simple scheme, right? And basically, given this, we can get a point total for every, every item. Sorting these point totals will give me a ranking from best to worst. Any question? That's what we call Borders' method. Any question about this scheme for coming up with a, a ranking of the people? Okay, is there any decision, any freedom we have here to make one decision, to change this approach? Okay? Or is this a completely fixed or deterministic thing? What freedom do we have in designing the system? Does anybody see any freedom? What freedom that we have is about these weights. I assign the weights of 1 to 5, just a linear weighting scheme. Is a linear weighting scheme the best weighting scheme? The answer is it depends, right? But in principle, I don't really like the linear weighting scheme for many things. Why is that? Well, linear weighting schemes kind of would imply that what's the difference between, if we had a linear weighting scheme, the difference between being first and last and second in our weighting scheme was worth how many points? 1. The difference between being 117th and 118th was how many points? 1. Do we want that to be the same contribution or not? If we do have equal confidence in our judgment at all points in the scale, then linear weights make a lot of sense. But generally, at least when I'm thinking about my opinion of the students, the end of the semester, I bet you the students on the top, I think I will have a pretty clear opinion on who's best and who's not. There's probably a bigger difference in the person who stood out the most and the person who stood out second most than the person who came in 119th and 120th, right? I will also have a big opinion of who is the biggest disaster in this class, I suspect, okay? And the one who was second most of a disaster, right? So with that kind of reasoning, generally weights on some kind of a normal or bell-shaped curve probably make more sense right? We want the difference between the first and the second point. So what did I do here? Here, you see that my pink thing is a normal distribution. My blue lines are samples, okay? I have sampled equally spaced probabilities in the normal distribution, right? The x-axis is the value, the y-axis was the probability. By sampling at equal probability intervals, notice that the lines are much closer together near the center than they are at the tails, okay? And if we use these kind of normally distributed weights, then differences at the tails has a bigger impact than the differences in the middle. Any question about that? Okay. Maybe it's symmetric. Maybe you could imagine a world where you have a good opinion. You know what people are like at one end, but the other end it's all a sea of chaos. Okay. Maybe you want to sample from a half normal. Okay. Any questions about that? Any questions about Borda's method? Another way that we could think about this, like there was a question on the TV in TV land a little while ago about what if we think this is a network. If we think back of having binary votes, me beat you, one way I could interpret that is as a directed edge. You could imagine building a graph or a network where the vertices are the items, and there's an edge from I to J every time I beats J. Maybe the edges could be weighted by how many times I beat J, okay? Maybe you could have multiple edges, I beat J, I beat J, I beat, but the basic principle here is you end up with a directed graph. And the question of trying to come up with an ordering from best to worst, if an edge goes from me to you means I'm better than you, okay? If the edge means, dominant or beat or something better, then one way that we would think about getting an order, you guys all know about topological sort. What is topological sort? Given a directed acyclic graph, a DAG, actually, let me see. Okay, find an order of the vertices from left to right such that all the edges go from left to right. In this particular example, there is an edge from A to B. There is an edge from B to C. There is an edge from C to E. There is an edge from C to D. There is an edge from G to D. From D to E, from D to F, and from E to F. All the edges go from left to right. That means that this ordering is completely consistent with all the I'm better than yous, right? And sometimes it turns out there can be multiple such orderings. This is another ordering consistent with that. But the good thing is if you have a directed acyclic graph and the votes form a DAG, then the question of is there an order that completely reflects all of that data, okay, consistently, that is topological sorting. Any questions about it? The good thing is topological sorting can be computed in linear time, right? What's the limitation of this method, though? Is there any problem here?
Not one answer.
What?
We can have multiple answers.
You could have multiple answers. Yeah, that's, I guess, a problem. One thing you could do, I guess, if you had multiple answers, you could have a battle, okay? Maybe you now add one more vote where you have A fights B, A fights G. I think if A fights G, I think that pretty much gives you the answer here, okay? What's a bigger problem? Okay, Different points change the ranking. Okay. What I would be saying is, I wouldn't call them points, but I would say, what if there was an edge like this? Suppose the results of your comparisons are not completely consistent, right? Certainly in sports, there is an upset from time to time. There are people who will be accepted at Stony Brook in Buffalo and end up going to Buffalo. Okay? Okay? Should it happen? Maybe not. Okay, but does it happen? Yes, I'm sure it can happen, right? Upsets. If there's inconsistencies, we no longer live in a topological sort world. Does everybody see that? So what would we do? Well, for general graphs, what we're looking for is we would like to find the order, not an order that avoids any conflict. Because the moment you have a cycle in the graph, if there's a directed cycle in that reference graph, there's going to be conflicts. The natural thing to want is the order that minimizes the number of conflicts. Does everybody kind of get that idea? There's a well-defined problem here. The input is a directed graph. Find me an ordering of the vertices that cut the minimum number of edges. Okay? In this case, here I have a graph which has a lot of directed cycles. If I delete these 3 edges, now what I get is a DAG. Okay? What I really want to do is to find an ordering. For any ordering, there's going to be a certain number of edges going the wrong way. And I want to find what is the ordering that would minimize the number of wrong way edges, right? And if we do that, what do we have? Well, the problem of doing it, okay, in a general graph is no longer linear. This problem is called feedback arc set, and it's an NP-complete problem. So the good news is this is a general way of ranking things if you have binary comparisons. The bad news is that it's a NP-hard problem. The reasonably good news is that there are natural heuristics that will do a good job. Okay? You can imagine starting out by ordering them based on how many edges they have coming into them versus going out of them, and then wiggling and adjusting the order to move vertices to where they kind of should be. Okay? Any questions about it? Should be clear this would be a desirable way of thinking about it. It should be clear that unfortunately it's NP-complete, but it's still something we would like to be able to do. Any questions? Which ranking system is the best one? Okay? And now you're seeing I've got all kinds of different methods. Okay? What is the best way to take, let's say, paired comparison, let's say voter ranking data, and come up with what is an order of the candidates that is the most meaningful, the best one? An interesting thing is that there is no best way of doing it, okay? And in fact, in some sense, by some theory, there is no decent way of doing it, okay? We talked about using Borda's method. We could talk about building these directed acyclic graphs or something like that. There's a famous theorem called Arrow's impossibility theorem, which states that however you design, this is more a famous theory in things like political science. What is the right way you should consider votes where everybody ranks all of the candidates from best to worst? Okay? Should we take the number of times that they've come in first? And that's always the winner. Or should we use a Borda's method, maybe with a normal or maybe with a linear? How should we do it? What Arrow proved was that there is no way to come up with a way to combine the votes that will satisfy all of the following properties. that seem like they're things you would want, obviously, in an election system. One is that it ranks all the candidates. Okay? After the election, candidates A and B should know whether A did better than B in the election, or if they did the same. Okay? That seems like a reasonable outcome of an election. It would seem to be reasonable that it should be transitive. That if A beats B and B beats C, then A should also beat C, right? If I get more votes than you, and you get more votes than the other guy, I should get more votes than the other guy. It should be true that if everybody likes me more than you, I do better than you in the election. Okay? It should be true that the outcome of the election should depend upon all the voters. One way you could make a decision is have there be one vote. We take all the voters and throw everybody else out except Skinner's vote. Okay? If there was a dictator, okay, you might be able to come up with a convincing order reliably. But we would like it to account for all the voters, right? So we don't want there to be a dictator. And the preference of A to B should not matter on how you score other candidates. It makes sense that if you want to think how did A do compared to B, okay, even if there are a lot of other candidates on the ballot, okay, they shouldn't necessarily impact the outcome. And what Elo's theorem shows is that no matter how you design an election system, there is no way to make sure that all of these things happen. There is no right way to run a democracy. There's a right way to run a dictatorship, okay, and that people discovered a long time ago, right? But what's an example of the kind of weird things that happen in election systems when you have more than two candidates? Here's an example. Suppose we have three different candidates, red, blue, and green, and we have three different voters, okay? What you call it? Voter X liked red, then green, then blue. Voter Y liked blue, then red, then green. Voter Z liked green, then blue, then red. Looking at this, okay, what do we think that red and, who do you think is better, red or green? Who do you think did better in the election? If you look at this data. They did the same, right? Red won according to, got finished first and second. Basically, both red and green had one guy that voted them first, one guy that voted them second, and one guy that voted them third. So my view of this would be they did the same, right? And it's perfectly fair to say that three's rankings were the same. But what happens if we delete blue? Should that affect the relative order of red and green? It shouldn't be. In some sense, you don't want that to happen, right? That's one of the things that we have here, right? But if we delete candidate 3, now who won the election? Who's better, red or green, if we delete candidate blue? Red won this one, red won this one, red lost this one. If you delete blue, suddenly red is the obvious winner. Okay? Does everybody see what the kind of contradiction is here? That violates one of the properties that we kind of talk about. So what is the best possible ranking system? Best possible way to combine votes? It doesn't exist. Okay? That said, there are meaningful ways of doing this that satisfy, a weaker set of properties. Okay? and that fit well in our system. And so we should have some humility here about what our voting system is. Any questions? But that said, there are ways you can come up with rankings, and they are natural and they are reasonably good. Any questions? If not, that's what I'm going to end over here. And have a good weekend, and I will talk to you guys on Tuesday. Okay, bye-bye.